All right, today we're going to be talking about finding the equation of a line that is parallel to that equation and also perpendicular to that equation. All right, so we're going to be working with the different forms of equations that you know, whether it's slope-intercept, point-slope, or standard form. So just make sure that you are keeping up with that and understanding what I'm talking about as I'm talking about it. All right, so the first thing we're going to talk about is finding the equation of a line that is parallel to another line. So our rule is if it's parallel, the slopes are the same. So our slopes are the same. I really can't write today. All right, so what we can do here is, in this particular example, we're saying write an equation of a line that passing through the point -1, that is parallel to the line with the equation y equals 2x minus 3. So right away we will know one thing. We know the slope. The slope of this particular equation is 2. So our slope of our other equation is also going to be 2. All right, so what I can do is I can actually use the point slope form to make this really easy. And I can say, okay, well, I can go y minus 1 equals my slope, 2x. Normally it would be minus -1, but I'm just going to say plus 1. And there's my new equation. Okay, now if I wanted to graph this, I could actually just graph this first line. Start at my y-intercept, which is -3, rise 2, run 1, rise 2, run 1. It's a couple times. Okay. Now, in this particular case, we know that it has to go through -1, 1. And we know our slope, so we can go up 2 over 1, up 2 over 1. And if you notice, we have our original line, black, and I'll make our second line this weird orange color. And as you can see, they are parallel. All right, so it's just as easy as that. It's not too difficult. Okay, so we'll just do one more, or actually this is the exact same example pretty much. Okay, so that's parallel. Now perpendicular is a little bit different. The perpendicular lines are actually have different slopes. So I'm just going to say it's so perpendicular lines, the slopes are the negative reciprocal of each other. Okay? All right, so what I can do here is I can actually say, all right, well, in this particular example, it says write an equation of the line passing through the point 2, 3 that is perpendicular to the line with the equation y equals -2x plus 2. So since I know that my equation is going to be, or my slope is going to be the negative reciprocal, let's just figure that out now. So we're going to say m is going to equal, well, we know our original slope was -2. So the negative version of that is going to be positive, in this case, the opposite form. And the reciprocal of 2 is 1/2. So in my point slope form, I can say y minus 3 equals 1/2 x minus 2. And there's my equation. So let's just graph this to make sure. So I'm going to graph my original line. My slope-intercept is at +2, or my y-intercept, excuse me. And now I'm going to go down -2 and over 1, down 2 over 1. All right, graph this line real quick. All right, and then I'm going to do my other line, this one, which we know is going to go between 2, 3. And from there, I'm going to say, okay, I'm going to go down 1 over 2. All right, so we're going to go over 2, up 3. All right, so start at our starting point, 2, 3. And then we're going to go down our slope. We're going to go up 1 over 2, up 1 over 2. Just go this way a little bit. All right, and then I'm going to graph my line. Do it in that weird orange color again. And as you can see, these two lines are now perpendicular. All right, so it is as easy as that. I have one more example here if you want to try it. It's just working with the perpendicular again, passing through that point -1, 4, and being perpendicular to that equation y equals 3x minus 5. Come in with any questions tomorrow, otherwise you should be good to go.